Hi everyone, it's me again, Lena, and in this video I would like to present you a brief introduction to assignment 4 CSC. What this CSC means, I will explain to you right now. So attention, there are two different assignment 4s. So assignment 4 CSC is for computer science connected studies. So if you're studying computer science, information and computer engineering, software engineering and management, there is a different assignment for you. So you do not need to watch this video, but you need to watch the A4 CSF video instead. So you can leave now. All the information, all the general information will be included in both videos. You don't need to continue watching this video. All other studies, so if what you're studying is not listed above, please stay here and watch this video. And this assignment is for you. So what is A4 CSC? This is what we call the express scanner for plagiarism. And your task is to implement a program that reads in two texts from a file and then splits each text into tokens. That's like small parts of all the words. And then checks if the same token appears in a similar position in both texts. And from this, the program should calculate a similarity score of the two texts and then create a report file. The deadline for this assignment is the 15th of January at midnight, and the assignment is worth 40 points. So this is much more than the previous assignments, and it's also more work. So please keep that in mind and start early enough. Also, what's new for assignment 4 is that there is a minimum requirement. So if you want to get a positive grade on the course, you need to pass 50% of the public test cases for assignment 4. In this case, this would be 4 out of 7 public test cases. So specifications, some more information on that. There's, once again, the general specifications on the course website always count, with the memory management section as well. But there are some additional specifications for this assignment. In this case, there are that each token must be stored as a struct, all tokens must be stored on the heap, and the texts must be read in dynamically using reallog. So please follow these specifications. Yes, and now I will give you an introduction about how the program works. This is all explained in more detail in the assignment description, but just so you have an easier time reading it, I will give you some examples now. So first of all, when starting the program, you have 3 command line parameters. One is the path to one file, the second is a path to a second file, and then the third is a program mode. There are 3 different program modes that are possible. First, there is the tokens mode, which creates the before mentioned tokens from the texts and prints them. Then there is the scan mode, which compares the tokens from both texts and prints the result. And then there is the report mode, which creates a report file. And there, what's different to the previous assignments is that in this case, there is no user input during execution. The program only behaves in a certain way specified by the program mode that is given as a command line parameter. So if you want to choose a different mode, the program needs to be restarted. So no user input during execution. And now I will give you an example for what this tokens mode should do and what it should look like. For example, I'm starting this A4 CSC, I give it the path to one text, I give it the path to a second text. So these are text files that contain texts with words. And then I tell it, yeah, I want to start this program in tokens mode. And then the program should split both these texts into tokens. And there are some rules for the splitting. First of all, the end of a line or a space ends a word and also ends a token. And then each token string, so each part of a word that is a token, has at most 4 characters. And you also need to store the position of this token inside the word, like if it was the full word, if it was at the beginning of the word, if it was at the end of the word, if it was in the middle. You need to store that somehow. Then numbers are treated the same as letters. And there are some special rules for treating special characters at the end of the word. These special characters are listed in the assignment description, which ones should be handled like that. And it's basically punctuation. So if you have a dot at the end of a sentence, then there's a special rule for how that should be treated. So let's look closer at an example. For example, in this text A, I have the following contents. I have this line and this line. And now I want to split this into tokens because I chose tokens mode earlier, or the user chose tokens mode when starting the program. So let's just go through the rules. First of all, the end of line and a space ends a word or a token. So you can see the red lines here. All of these should be split in the text. Then we also have the rule that the token string has at most 4 characters. So for any of these that are longer than 4 characters, I need to split them again. And for this, I start from the beginning of the token and then count 1, 2, 3, 4, and then it needs to split. And everything that's left over should be in the next token. So at the end of the word, there might be tokens where the string is shorter than 4 characters. Also, if the word is shorter than 4 characters, then the token is shorter. And then we have this special rule for treating characters at the end of the word. One of those is a colon. And these should be split off from the word and then treated as a separate token. So here we also need to split these two. If any of these special characters occur in the middle of a word, then you don't need to handle them separately. Just if it's like the last position of a word, as in this case, there's a 4, then there's no space, and then there's this colon, then we know this is some kind of punctuation, and we need to split it off from the word. So now we found all the tokens in this text, and let's look at what this looks like. So we have in total 9 tokens, and here you can see them listed again. Like this is the same split as was shown above, and just listed. And each of these has a string, which is listed here, and then now we need to figure out which position these tokens have. So this is always the position inside the original word, is what is meant by that. So first of all, we have 4 different possible positions. Either the position can be full, which means that this token takes up the whole word. Then it can be start, which means the token is at the beginning of the word. It can be end, token is at the end of the word, and it can be middle, which means it's neither start or end. If you have a really long word, there can be multiple middle tokens. So for example, if we look at this one, SDG, this is a whole word, so the position is full. Goal, also this one ends in a space here, so this is a whole word, position is full. Then for the the colon has been split off, so this is separate, and then we have the whole word, so the position is full. Then this is the special rule for special characters. These split off special characters always get the position full. And then for this one, for quality, we have qual, which is the start of the word, so position start. Et is the end of the word, so position end. Same for education. Educ, first 4 characters is the start of the word, position start. And these 4 characters are in the middle of the word, position middle. And the N is the last part of the word, so it gets position end. And you need to do this for text A and also for text B. So you get, the texts might be of different length, so you get a different amount of tokens, 9 tokens for text A and 11 tokens for text B. And for the tokens mode, you just have to split this and then print them out in a certain format. That's everything for tokens mode. Now we move on to scan mode. So as you can see here, once again started with 2 input files, and then we give it the parameter scan, so we want to start it in scan mode. For this, you need to create the tokens exactly like in tokens mode, so you need to implement tokens mode first. And then for each token from text A, you check if any tokens in text B in a certain radius around the position that you're currently looking at in text A are exactly the same. So the string and the position needs to match for a token to be the same. And then if you find any that are the same, you mark them in both text A and text B and print them out once again with these markers that show you which ones were matches. And then from these matches, you can calculate a similarity score, first for text A, then for text B. So what this looks like is it's the same example as before. So we now have split our texts into tokens. The radius depends on the number of tokens in the text. In this case, it is 2. It is explained in detail in the assignment description how to calculate this. And then I will start in text A. I will go through all the tokens and see if inside this radius, so we have radius 2, like from our position 1, from our token ID 1, we have 2 to the front and 2 to the back. This is the radius we need to look at. Here you need to make sure that you do not run out of bounds, because you also need to check this for the first one. As you can see here, there's like some kind of problem here. And for this, you then check, can I find inside this radius any tokens that are exactly the same? And in this case, it's easy because we have exactly the same token in the same position. But also if this SDG full was the second token in text B, it would also need to be marked as a match. And also if it occurs multiple times, all matches are marked as a match. So, and then you keep going. You're like, oh yeah, and we'll now check the second token from text A. Do I have goal and full inside the radius? Yes, I do. Then I check the third token from text A. Do I have a 4 inside this radius and a full? No, nothing. Then I have like the colon and full. Yes, this is a match. Then I keep going like this and look for matches, and in this case there are no more. And then here as well, check, make sure that you do not run out of bounds. And then from these numbers, like the total number of tokens per text and the matches per text, you can calculate a similarity score. How you calculate this exactly is described in the assignment description. And then you print out these results. And then there's the third mode, which is report mode. You start it once again with the 2 input files and then give it the program mode parameter report. And for this, you need to have implemented tokens mode and scan mode first, because inside the report, you will print results from both these modes. So you create a report file that contains, first of all, the similarity score for both texts. So this is this print here. And then the original text, so the words need to be put together again from the tokens. And any words that have a match inside them, one or multiple matches inside them, will be marked with underlines around the word. So for our example, we had SDG and goal and the colon as matches in both texts. So these now have in the report underlines around the words. But also if, for example, something in the middle of a word was a match, then the whole word would be marked with underlines around it. So you need to put the words together again. Once again, explained in detail in the assignment description. All right, so how should you get started with this assignment? First of all, you need to define your token structs. You need to think about how you want to store them, in what kind of data structure. And then you need to read in the input files and find an algorithm to split the text into tokens. And as I said already, the tokens mode needs to be implemented before the scan and the scan before the report, because they build on each other. Yes, I think that's it for the explanation. So now I will just give you a short example how to run this. So I'm in the VM again. This is our repo, and then let's do, yes, because here you can do multiple different make commands. The make commands now depend on which mode you want to start it in. So if I do make run tokens, then it will be started in tokens mode. So this is the example I showed in the slides as well. You can see that it tells you how many tokens were in each text, and then it lists them in a certain format. Then I can do make run scan, and then this will just show you the output for if the program is started in scan mode. Let me do it like this. Once again, I have the tokens listed, but now they have like an exclamation mark in front if they were a match. As you can see here, the SDG has an exclamation mark, and in the second text as well. And also the similarity score is printed. And then I can do make run report. So now the output in the console will only be, yes, a report was created. But if I now look in the location reports, and then it tells me what it is called. Reports, I can do this one. I will see what's inside the report. I can check what's inside the report, and as you can see, it has these words with underlines around them for the matches. Yes, that's it for the different make run commands. But you can, of course, also do make test, as always. Wait a bit. And then we should have a test report. Where you can see the results, as with the other assignments. Yes, I think that's it for the example. I already told you how to get started. If you have any further questions, please ask via Discord. There's the A4 CSC form. Please make sure to put your questions in the correct form so we know which of the two A4 assignments you're asking about. You can also ask in person at the question hour. This one is currently planned for the 9th of January. As always, announcements will be on Discord. Please start early. As I said, it is bigger. This assignment is bigger than the previous one, so you will need more time. And also, no plagiarism. One additional thing, the repositories will automatically be created for you, so you should get the correct repository for what you're studying. But if you think that there is a mistake, please tell us right away before you start implementing. If you think you got the wrong assignment, please tell us. Hopefully it will not happen, but if there's an error, please tell us. All right, that's it from me. Good luck with the last assignment of the semester, and goodbye.